Hey guys, I'm going to do problem number 6 from the energy number 6 worksheet, and the problem reads: a 1400 kilogram car is traveling on a level road at a constant speed of 27 meters per second, or 60 miles per hour. The drag force exerted by the air on the car and the rolling friction force exerted by the road on the car add to a net force of 680 newtons pointing opposite the direction of motion of the car. A. Determine the power due to the work done by this opposing force during this process. B. The car instead drives up a 4-degree incline at the same speed. Determine the power due to the work of the opposing friction-like forces and the force exerted on the car by Earth during this process. Express both results in watts and in horsepower. 1 horsepower equals 746 watts. So the first thing I did was make a sketch of the situation, and I had a car in its initial and final phase with the initial velocity to be 27 meters per second, and I said the car was traveling in a positive direction. And the system in my sketch would just be the car, because the external forces are the friction forces. So for part A, we use the equation power equals work divided by change in time, and we know work to equal force times cosine theta times change in distance. From here we could plug in force to equal 680 and theta to be 180 because the forces of friction travel in the opposite direction of the car's motion, which I said was positive. So this would be in a negative direction, which is why it's cosine 180. Change in distance divided by change in time is the same thing as velocity. So we get 680 times velocity. Our given shows that velocity is 27 meters per second, so we could do 680 times 27 to get 18,000 watts. And from our conversion factor, 1 horsepower equals 746 watts, we could change 8,000 watts to get 24 horsepower. Now for part B, the car drives up a 4-degree incline with the same speed, but with 2 forces, the friction-like forces and the force exerted on the car by the Earth. We use the same equation again, power equals work divided by change in time, and we know work to be force times cosine theta times change in distance. Now for force, we have 2 forces, the force of the Earth and the force of friction. So we know the force of friction to equal 680, and the force of Earth would be equal to mg sine theta, where theta equals 4, m is the mass, and g is acceleration due to gravity, times cosine 180 times change in distance divided by change in time. The mg sine theta part would come out to be 970, and you'll have 680 plus 970 times negative 1 times change in distance divided by change in time. Again, power has to be a positive quantity, so it would have to be 1,637 times velocity, which we know to be 27, and if you multiply those, you get 44,000 watts. And using your conversion factor, you get 59 horsepower. So that's how you solve a problem using power and watts with degrees. And I hope you have a better understanding of how to do these type of problems now. Thanks for your time.